This is 12.3 of Algebra. So we're going to look at measures of central tendency. So that's the mean, the median, and the mode. Kind of different ways of saying the average of a set of data. A specific word you should know is an outlier. So a piece of data is an outlier if it's really, really big or it's really, really small and it doesn't seem to fit with the other ones, okay? And outliers usually throw off your average. So here's mean, median, mode, a review. The mean is when you add everything up and divide by the number of pieces of data that you have. That's good to use when there isn't an outlier, okay? When there's an outlier that totally throws off the mean. The median is your middle piece of data, so you've got to put them all in order, and it's the one that's in the middle. And then the mode is the one that happens the most often. So we're going to find the mean, median, and mode, and we're going to use the data that they already used, but we're going to take out the piece that's 189, because that's an outlier. Okay, so it's listed here, easier to see than on the screens. So first, probably that's easiest is to find the median. So if we're getting rid of 189, okay, that's not on our list. Once you've got your pieces in order, okay, so these are already put in order, cross off one at the beginning and one at the end. Beginning and end. Beginning and end. Beginning and end until you get to a middle piece. Okay, sometimes you get to the middle and you have two pieces of data. Then you need to add them together and divide by 2 to find the middle of those pieces, okay? Since we've just got one in the middle, our median is 109. Median is 109. Okay, so let me erase that so that we can actually see all of our other stuff, because that's a nice list, I think, to look at. So the one that happened the most often, the mode, would be 104, right? 3 people got 104. So our mode is 104. And then we got to find our mean. So our mean involves adding everything up. Okay? So let's do the mean up here. So I'm going to add all those pieces together. Okay? So 104 plus 104 plus 104 plus 109 plus 113 plus 117 plus 136 gives me 787. And then we've got to divide it by the number of pieces of data we had. So we had 1, 2, 3, 4, 5, 6, 7. There are 7 pieces of data here. Okay, so I'm going to divide this by 7. And if I divide it by 7, I get 112.4. So I'm just going to round this to be 112 because that doesn't make sense in terms of bowling. So my mean is 112. And then we can decide which one fits the best. It's hard to say in this. I'd say not the mode, right? Because the mode was at the beginning, so that doesn't really fit in the middle. Maybe the mean's the best. You could argue that the median's the best, one of those two. When they did it with including 189, then the mean doesn't fit very well. So the median probably fits the best then, right? If there's an outlier, the mean isn't going to give you a very exact answer. Okay, so now we're going to try to figure out one of the pieces if we already know what the mean is. Okay? So we're going to adjust theirs a little bit. So you took tests, and you got an 80, an 93, and a 91, okay? And there's one more test coming up. So test is coming up next week, let's say. And you want to know, how well do I need to do on that to be able to get an average of, let's say, 89%? Okay, so you want an average of 89, and you don't know what you got for this next test, obviously, right? You can hope that you get 100% on the test, or you could not study and say, I'm not going to do well on this test at all. You don't know the actual score that you're going to get, right? So when we don't know the actual score, or the actual number that we're using, that's when we use a variable. So I'm going to use x. And I'm going to find the mean of these. So 80 plus 93 plus 91 plus x divided by, we've got 4 pieces there, and I want an average of 89%. So I'm going to add those 3 numbers up. So 80 plus 93 plus 91, that gives me 264. So this is 264 plus x over 4 equals 89. So I'm trying to get the x, right? I want to know what score do I need. I'm going to need to get rid of that 264, and I'm going to need to get rid of the 4. I need to get rid of the 4 first because it's affecting both the 264 and the x. So I multiply by 4 on both sides because 4 divided by 4 is just 1. So 264 plus x is equal to 89 times 4 is 356. And then I can subtract 264 from both sides. And I get that x is equal to 92. So I need to get a 92% on the next test if I want to have an average in the class of 89%. One thing to note, let's say I was aiming for something that wasn't possible. Let's say I was aiming for an average of 100%. Okay? When you did the subtraction part here, you would get an answer here that would be over 100%. It's like 112% or 110% or something like that. And that's not possible, right? We're assuming there's not extra credit. So sometimes you could be aiming for an average that doesn't work, and your answer here won't make sense. It'll be over 100%. Okay, so a measure of dispersion. If I went outside with a group of students and I said disperse, they would know to separate, right? To spread out. So our measure of dispersion tells us how spread out our data is. Okay? One way we do that is using the range. Okay? So the range of a set is when you take the biggest number and you subtract the smallest number. So we're not going to do this whole problem here. Let's just find the range of these guys. Okay, so here's my data. I need to figure out my biggest number. Well, that's 7. And my smallest number, which is 1. So then my range is going to be the biggest number minus my smallest number, which is 6. So my range is 6, and that tells me how spread out my numbers are. Let me give you a different set of data. So I'm going to give you 2 different sets, okay? Let's have, 10, 30, 35, 49, 56, 22, 28, 40, and 11, okay? So my biggest number is 56. My smallest was 10, right? So 56 minus 10, that's 46. Okay, and I'm going to find the mean of these. So I'm going to add them all up. So 10 plus 30 plus 35 plus 49 plus 56 plus 22 plus 28 plus 40 plus 11. And that gives me 281. Okay, and there's 9 pieces of data here. If I divide that by 9, I get 31.2. Okay, now I'm going to give you 9 other pieces of data, okay? 10, 12, 25, 20, 29, 15, 18, 22, and how about 25 again? Okay, so 9 pieces of data again. Here's my biggest number, or smallest number, sorry, and my biggest number. Hey, they're in the same spots. So 29 minus 10, my range is 19, okay? So I've got a lot smaller range over here, right? My range over here was 46. My range over here is 19. So comparing these two data sets, I should say, this one is a lot closer together. They're more compact. And if I find the average, so 10 plus 12 plus 25 plus 20 plus 29 plus 15 plus 18 plus 22 plus 25, that gives me 176. Divided by 9 gives me 34. So Sorry, I typed that in wrong. We get that doesn't make sense. We get an average of 19.5. There we go. Which of these averages do you think fits the data better? Do you think this data has an average of 30? Does that seem to fit it well? Or does it make more sense that this data has an average of 19.5? Well, I'd say the second one, right? They're a lot closer together, so their mean fits the data better. It's a better predictor of it. Whereas when you have a really big range, your mean isn't going to fit it very well. And there's your homework.